Okay, let's look at the function notation. Right? So here's an example. Right? So if you have f of x is equal to x squared minus 1. So the formula is given. Right? This is how we evaluate f of 2. Right? So f of 2, which means that whenever you see x, we're going to replace x by 2. Right? So you have x here, so it's going to be 2, and it's get squared minus 1. Right? So f of 2 is 2 squared, so which is 4, minus 1, so it's 3. So f of 2 is equal to 3. Right? About f of negative 3, same way. Every time you see x, we put whatever between the parentheses. So it's going to be a negative 3, right, squared minus 1. Right? So that will be negative 3 squared is a positive 9, minus 1 would be 8. Right? So f of negative 3 is 8. Alright, so using that function notation rule, what about something like this? What if somebody gives you f of an apple, right? What does that mean, right? We know exactly what it means, right? So f of an apple is going to be an apple squared minus 1, right? That's how the function notation works, right? Once you realize that, everything else is very, very simple, right? So let's look at something called difference quotient. Right? Difference quotient is this expression down here. So this guy is called the difference quotient. Maybe I'll just bring the arrow down here. Right? Let's try to simplify this expression. Right? Given that, say, g of x is 3x squared plus 5x minus 8. Right? So let's do one by one. Let's try to find a g of x plus h. What does that mean? Right? So this means that every time you see x in the formula, we replace it by quantity x plus h. Right? So let's do that. So this is going to be 3 is already here. So now I see x. So instead, we're going to put the quantity x plus h, right, squared, right, plus 5 times, I see x. So we put x plus h, right? Then we subtract 8, right? So this is equal to, we just need to simplify it, right? So it's a 3 times, all right, so I'm gonna multiply this out. So x plus h squared would be x squared plus 2 times x times h, so 2xh plus, right, h squared, right? So that's that. Right, then I'm going to distribute 5 to x. So we'll get 5x, right? And I'm going to distribute 5 to h. So that'll be 5h. Right? Then you have a minus 8 at the end. Right? Then I'm going to just distribute 3 to these 3 terms. We get, it gets a little bit messy, right? Right, 3 times x squared. So maybe I'll circle this. So you have a 3x squared. Right, 3 times 2xh. So that would be 6xh. So 6xh. And 3 times h squared. That will be 3h squared. Right? Then you have plus 5x 5x, so that's this guy, plus 5h minus 8. All right, so that's the answer for f of x plus h. All right. All right, so let's do g of x plus h. Oh, actually, I said f. G of x plus h minus g of x. All right, so all we have to do is just copy the answer from the first one. So you have a 3x squared plus 6xh plus 3h squared plus 5x plus 5h minus 8. All right, then we have to subtract g of x. G of x is the original formula. So you have a 3x squared plus 5x minus 8. All right, so we just have to simplify. You see that there's a 3x squared and 3x squared cancel out. And there's 5x here minus 5x cancel out. All right, negative 8 minus negative 8 cancel out. So what's left is these three terms. You have 6xh, 6xh. Right, there's 3h squared plus 3h squared, right? And the last one is 5h. All right, so that'll be the answer for the second one, g of x plus h minus g of x. All right. All right, finally, we can get to the difference quotient, g of x plus h minus g of x all over h. All right, so let's do that. So first, on top is exactly the same as the second one. So you have a 6xh plus 3h squared plus 5h all over h. Right? Luckily, all three terms on top has h in it, so I'll factor h, right? So if you factor h from the first term, you have 6x left, right? Factor h from 3h squared, you're going to have 3h left, right? Factor h from 5h, you're going to get 5 left over. Right, we're going to divide by h. Right, so h divided by h is 1, so we can cancel those out. Right, so what's left is quite nice and simple. 6x plus 3h plus 5. Right, so that's the simplified difference quotient. Right. That's it. So this is the function notation. I hope that this was clear.